Let's make a face part 6, Compartmentalizing Complexity. We'll discuss semantically meaningful JSX refactoring, using nested React components, how to debug a reference error if you see one, the special children prop of React, how refactoring lets complexity scale, small multiples with JSX and Array.map, and using randomness to generate graphics. We have refactored these components so that we have background circle, eyes, and mouth. And I find this to be much more readable than what we had before. We have semantic meaning in these names themselves. The last frontier here is we've got this bit of sort of cryptic code that's not semantically meaningful. What I would like to do is replace this with something meaningful like, I don't know, face container. We can say face container, unindent that, not face container. Now let's try making this component. Const face container equals a function that returns, and I'll paste the JSX that I had cut from earlier. We define our SVG element, our group element, and we need to close these, so I'll say not G, not SVG. And what we want to do is put the stuff that's inside, like nested inside of this, we need to put that in between these tags here, inside of this group element. And how the heck are we supposed to do that? This is where we can leverage a very special prop called children. We can just say props.children. And we need to take props as input. And boom, it works. And again, we can use the same ES6 destructuring syntax as before to destructure children like this. We can't make this a module yet because it refers to width, height, center X, and center Y. So we could add these as props, width and height. And we can also add center X and center Y. Now we can pass in these props. We pass in width, height, center X, and center Y. All right, now we can actually move face container into a different module. We can say export const face container, and then I'm going to cut this text, make a new file, facecontainer.js, and then in facecontainer.js I'll paste that component, and then in index.js import face container from /face container. Now we're ready to make the ultimate component, namely the face component. But why would you want to do this? See, conceptually, the app component it has a bird's eye view of things, and it's sort of the orchestrator. And ideally, the app code, when you read it, should just be really simple to read. It should just say, okay, here's a face. And then, like, these even though they're relatively high level compared to our SVG elements, they're still pretty detailed. I mean, the app shouldn't really need to know that a face has a background circle, eyes, and a mouth. It should just know that there's a face. So let's do this refactoring, where we take all this stuff and we make it its own component, namely the face component. Const face equals a function that returns the same JSX we had earlier. All right, it works. Now we need to go through the same exercise as before, where we need to pass in all these things as props. Width, height, center X, center Y, stroke width, eye offset X, eye offset Y, and eye radius. And I'll just reformat that long line to look like this. Now we need to pass in all that stuff. And that looks awfully similar to all these variables here. Maybe we can actually get rid of these variables. The only problematic thing is center X is defined in terms of width, so I think we want to just leave these two. And all the rest of this could be computed as the props as they're being passed in. So I'm going to cut this from here and paste it as the props to our face component. Center X is width over 2, center Y is height over 2, stroke width is 20, eye offset X is 90, eye offset Y is 100, eye radius is 40, mouth width is 20, and mouth radius is 140. And I'll reformat that little. This is not working. Do we have any runtime errors? Oh, it looks like I missed mouth radius. Mouth radius. Yeah, it's not in this list here, so I'll just add it. And I'm noticing too that width and height are required here, but I don't think we passed those in. So let me pass those in too. We pass in width and height, and boom, it works. All right, now we can actually move our face component into a separate file. So I'll make a new file called face.js. I'll cut all this code here and go over to face.js, paste it, and then use the export keyword. And then over in index.js, import face from /face. It's not working, but I don't need to look because I know that the problem is all this stuff is not being imported into the face module. So I'm going to cut these imports out of here and go over to face.js and paste them over here. All right, very good. We have completed the refactoring. Now everything is sort of on a need-to-know basis. The app only needs to know about the face and what values that it needs. And the face doesn't need to know anything about the parent component. It only needs to know about its children. The face needs to know about these components. And the app doesn't. That's the beauty of componentizing things. And consider the D3 arc import. That's only needed by mouth. The only thing that needs to know about arc from D3 at all is just the mouth component. This kind of refactoring with components and modules allows complexity to scale because it compartmentalizes the complexity. Having things on a need-to-know basis like this lets us express things in sort of a higher level language. For example, we could even have multiple faces. See, we could just say our app has 2 faces. And we're running into that React issue again where we can use a React fragment because our component needs to just return one thing. So we can return this React fragment. Now 2 faces are there. You can't see them because the width and height need to be adjusted. Let's adjust the width and height. Let's say 166. And we've got 2 faces, but now everything else is sort of off. So let me just make some adjustments. So I'll just tweak things until that face looks sort of right. Imagine if we did not have components or props or anything like that. Imagine how many different places I would need to change things in order to do that sort of adjustment. After you've done a refactoring like this, you can just change things all in one place. We can even make a bunch of faces. We can do that by starting with an array. Let's say 1, 2, 3, 4, 5. And then once we've got this array, we can make one face component for each entry in this array as follows. We can use array.map, and then we can pass in a function to map that returns a face. So I can take this face JSX here, put it into here, and then I'll just get rid of that other face. We don't really need that anymore. And now our syntax is sort of confused. We can just return array.map like this. And now we've got 5 faces. Let's say we want a certain number of faces. We can say range from D3. Let's import range from D3. And if we say range of 5, then we get an array with 5 entries. If we say range of 50, we get an array with 50 entries. How many faces can we fit here? We've got 5 by 3. So I'll just say 5 times 3. And it's getting a bit cut off at the bottom. Let me just reduce the width and height a little bit. Whoa, now it's 6 by 3. No problem. Now that we've got this set up, we can introduce random variation. For example, the eye radius, we can set to be 10 plus some random number. Math.random gives us a random number between 0 and 1. So if I multiply by 5, now we see some variance, some variation in these eye sizes. If we make it 5 plus math.random times, say, 10, we get even a wider variety. We can do something similar for mouth width and mouth radius. Also for eye offset x and eye offset y. Stroke width too. There we have it. That's how you can use React components and ES6 modules to compartmentalize complexity and express higher level thoughts, like let's make a bunch of random faces. Using these techniques, we have been able to transform what was once a smelly, dirty mess of code into a crystalline palace of well-isolated logic. These techniques allow us to compartmentalize complexity, and this allows complexity to scale, and this will become extremely useful when we start to make more complex things like interactive data visualizations. That's all for Let's Make a Face Part 6, Compartmentalizing Complexity.